TechnorazziLIVE, the program that lets you ask questions of metrology experts. I'm your host, Dirk Ducharme. Well, once again, we're back at Carl Zeiss Industrial Metrology, just outside of Detroit in Brighton, Michigan. If you remember our last episode at Zeiss, we took a close look at computed tomography, 3D X-ray, with Calypso software. Well, today we are also going to look at software and hardware, but with more of an emphasis on software. As test and measurement equipment gets more precise and more complex, the burden on software is twofold. It needs to be both more comprehensive while at the same time being easy to use. Add to that the increasing need for document control and traceability, and the need for flexible and easy to use metrology software becomes even more of an issue. Those of you who are working in FDA-controlled environments know exactly what I mean. So today, one of the two metrology products we're going to look at is the Zeiss Surfcom 2000, a surface texture and contour measuring instrument. We're also going to look at the ACCTee software that makes surface contour measurement both easier to perform and the results easier to document. We'll come back to that later in the show, but first, we want to look at some software that is very important for companies that need to control, monitor, and document the operations of multiple CMMs across multiple sites anywhere in the world. And to tell us all about that is Josh Smokovitz, who is the a product manager for Carl Zeiss. Do I have that right?
Yes, sir. Thanks for having me, Dirk.
Sure.
Yes, exactly. What you're talking about was the Master Control Center software, and I want to put a lot of emphasis on control. It's meant to control the entire CMM environment. So what I did, just to get a little bit of an introduction into this software, was starting with our metrology software, which is Calypso. So what we're going to do is start with is just saving a program. So the first area of control we're going to look at is the CNC version control is what we call it, which is a module of MCC that allows us to control and revision actual programs. So again, what I have here is just a Calypso program, and we're going to go ahead and save this program.
So this is just a regular parts program here you have done on Calypso. Okay.
Yep, this is just a simple parts program that I wrote as an example. So we're going to go ahead and save this. Now, once we save the program, then we're going to actually use the MCC software to go ahead and bring this into a server environment, and then also create a controlled revision of that as well. So now we're going to go into MCC. Now, the first thing that I want you to notice is that this is a completely web-based software. So there is actually no software installed locally on this PC to actually view and monitor this software as well. So it can be logged in from, as long as you're on the network where it's installed, you can log in anywhere and use the software as well. Okay.
While you're doing that, let me just remind our viewers that at any point during the show, you can send questions to techno-live@qualitydigest.com, and we'll answer them right here on the show, both during the segments and at the end. And the email address should be below your player. Sorry, Josh.
Okay, here we go. What we're going to do again is bring that program into the server environment as well, and then create a revision of that. Okay. So we'll go ahead and go into our module here. Now, what you can do is you can see that how you can actually sort them. It's really customizable. You can sort things any way you want to. So I'm going to go ahead and throw this, since it was a gear program, I'll throw it in my folder for gears. Now we're going to go ahead and add this inspection plan. Okay. So now once we added the plan to the actual server environment, we're going to see that it actually comes up here in yellow. So what we have to do is actually create that first initial revision. Okay. So I'm going to go ahead and open that program. Now what we can see in here is, first of all, the actual name of the program, and then also importantly what Calypso revision this was written in. People like to know as far as what revision Calypso is running in, as far as program compatibility, etc.
Now, would this also be an FDA issue as well, that everybody's running the same software?
There is traceability issues, so basically the more data, the better. So there's nothing going to be left out in this process. Sure. Now, what we're looking at here is the actual probe configurations used by the CNC program as well. So MCC will actually go inside of the program and actually pull out those probes so you can document those as well. And then we have over here a spot for applicable documents. So we can actually add multiple documents that will be bound to this revision copy of this program as well. So it's a way to control the revision and also any documents associated with it. So let's go ahead and actually add a document here. This is just a simple PDF.
Now these would be just documents that might be necessary just useful information for the operator, right? When they go to run this measurement program, they might want to know information on the probe, for instance.
Exactly. It can actually be multiple documents. So here I'm doing a PDF, but you'll see actually as well that I have attached the CAD model as well.
Sure. Okay.
So you can do different document extensions as well. So then once we attach our applicable documents, we're just going to go ahead and actually create a version. So we're going to go ahead and publish this version, and what this is going to allow us to do, or allow operators to do, is then run the program. So when I want to actually publish it, it's going to ask me for a comment. And this comment is very important for traceability of the document and revision history of the program itself. So I'm just going to go ahead and give this a name of initial release. And then we'll just hit OK. And now what it's doing physically in the background is it's actually moving it to a different spot on the server. And this allows us to control the document. It's going to attach, as we can see here, a version number, a date and time stamp, my comments, and then who actually made those changes as well. And now since this is a published version, operators on the production line will have the opportunity to run this program.
Okay, so this gives you version control of pretty much anything that you're uploading to the server, right? I mean, okay, somebody can be overseeing this, an administrator or something, and
exactly.
signing off on version releases and so forth.
This entire interface here can be designed to be completely passive and unknown to the normal operator.
Okay.
So the operator, what they would be able to see is whether the program is there or it isn't to run, but then there's all this attached revision history and information additionally as well. And you can control access as well to this. If certain operators need to see this information or read documents, they can do that as well.
Okay, so just so I understand how some of this works is, so you're an operator on a CMM anywhere in the world. You're getting ready to run a parts program. It's going to pull the latest parts program from the server, so they're always going to be running the latest program for what they're doing.
Exactly. So it will be running the program from the server, but we also have the opportunity to push the programs out as well in a scheduled manner.
Okay.
It just really depends on the customer requirements, and we're very flexible with that.
Okay.
Okay. So this is how you would fully control a document then. So then we can go back and actually see our full list of controlled documents. Now that we controlled the actual measurement plan, what about what comes off of the measurement plan, the actual results? Now before, if you have even one CMM or multiple CMMs, especially spread across the country or the world, it's very difficult to access documents that are on and stored on the local CMM. So what this new module will do is it will actually allow you to store all of your results in one location, and more importantly, have access to those later in a very easily searchable manner. So let's go ahead and go into our what's called our measurement database portion of our software.
So as the CMMs, no matter where they're at, as they're taking data, once they finish a measurement run, this data is automatically pushed up to the server?
Exactly. This data is automatically pushed up to the server, and then MCC will actually generate some extra info that's included as well.
Okay.
So what we see here, this is the main search screen where we can actually search by any or all of our header variables. That's usually decided by the customer. Not everybody has the same header variables, so this is something that we can completely customize to the customer's application.
Okay.
So we can, as an example here, the scenario would be that we want to search for any or all maybe parts that are ran for a particular program. So I'm able to actually search, in this case, we can just grab a program, and without filling any other search criteria, this is going to return me all the results that were ever run from this program, even if they were run at different facilities on different machines, etc.
Okay.
Okay. So let's go ahead and look for some protocols. So as you can see here, we have a list of PDF documents, and this is what the operator is familiar with on the bottom here. We'll scroll down to the bottom, would be the standard Zeiss custom printout. But again, like I was saying before, was that additional data that's actually attached to the measurement protocol. What we actually have is some additional header variables that are always passed through in Calypso. And then we actually have a complete traceable history of everything that happened with this document. So we also have the ability to monitor who is actually accessing the document, if it was ever printed off, if it was ever downloaded, and all these things are going to be documented with a date, a timestamp, and the person that did this action as well.
Which is critical, again, if you're working in an FDA environment.
Yes,
right?
because this actually provides the complete traceability of a document.
Okay.
Okay. So what we can also see is a few different things going on as well. We see a list of actually all the characteristics from that measurement plan. So what MCC does is it actually reads the PDF. This is what allows us to search it for any variable, first of all, but it also allows us to do some overall results as well. So if we just pick one of these characteristics inside of the program, we can actually see the last 5 runs in this case. Or if I wanted to, we can view the last 100 runs as well.
Okay.
So we can actually see in a little bit and analyze what's going on in our process as well. And again, this is some simple tools that we can use to even view multiple results over a duration from a number of different reports.
Okay, so what I'm looking at here, is this all data from one machine, or is this aggregated data across multiple machines running the same part?
Okay, good question. In this case, it's actually from one machine, but it wouldn't look any different if it was from all machines. This is just a function of how I search for the data. So if I wanted to search for data from multiple machines, I could just leave that search field blank for specifying a machine. Or if I wanted a particular machine, I can drill down and just choose results from that machine or a given time period, etc.
That's pretty cool. So that means that if you wanted to look at data, the same part, the same measurement across multiple machines, you would get, this would represent the aggregate of all of those, and you can actually kind of see how your process is working across the entire worldwide. Okay.
Exactly.
Right.
Yep. So this is how we would control the results or the reporting aspect of Calypso, the CMM environment. Now we have the actual during measurement process. What do we have the ability to do with when Calypso is actually running? So let's go ahead and take a look at those 2 modules. So what we have is the ability to monitor certain aspects of the CMM environment while the machine is actually running. Okay? For example, what we can actually do is use what's called a status monitor to view and visualize machine uptime, for example. So what I want to do is, just as an example, I'm going to search all the machines that we have currently in Brighton.
Okay.
And I'm just going to put in a date range here, some recent dates here.
Okay, while you're doing that, remember, all of you watching, that if you have questions for Josh on the Master Control Center, that you send your questions to techno-live at qualitydigest.com, and we'll have Josh answer them right here on the air.
All right. Perfect timing.
Perfect timing.
So what we have here is just a date range of the last 3 days.
Okay.
And then we also search from 9 to 5, because I know my facility doesn't actually run it at night. So I'm just going to search from the first core shift.
Okay.
Okay. So what we see here when we actually look at the data here is we'll actually see some very patchy data. Of course, I'm only searching from 9 to 5 every single day. Okay. Now, what we can do is just keep drilling into this information for a particular machine, let's say, and we can start seeing a whole bunch of runs back to back. So basically this machine was running just constantly back to back running these programs. So what I can do is just actually keep drilling down to, let's say, a 1 hour time frame. And we can see that this program was ran this many times in 1 hour. And then we can also see some additional information as well. Since all MCC works together, we can see our statuses listed below. So if we wanted to take a look at what some of these buttons will actually lead us to, for this particular run, it will actually take us to the measurement database for when that program was actually ran, so we can real-time look at what's being done and the results instantaneously. Or we can actually take a look at it's tied to the measurement database as well, or excuse me, the program database.
Okay.
So we can see which program was actually used to get these results during this specific time.
All right.
Okay. Now, the other thing that we can do is actually look at the overall machine information as well. So maintenance schedules and everything, again, is tied together in this complete database.
So that might be able, this would allow you then to, if you had a machine that maybe was giving out, looked like some spurious data that was outside of what you would expect, you can actually start drilling down to it even from this view right here.
Exactly.
Okay.
So the other thing that we can use this for is this view is nice, but we also have different views that we can actually look at to maybe monitor actual machine utilization as well. So when we look at when the machine is actually running and when it's actually off, we can kind of get an idea about, okay, how much is this machine used? So when we take a look here, we look at this one machine, this Acura, and basically it's running 99% of the time. So its utilization is very high. It's never off, okay? Whereas we look at this G2, and we look at the utilization, and 90% of the time it's actually off. So in a production environment, we might be thinking, okay, is there a reason for that? Do we need to balance loads, or do we need to shift some work around, etc.? Okay. The other reason that we might want to do this is to justify the purchase of new machines, for example. So if all our machines are at 90% capacity, we might, and we're going to launch a new product very soon, it gives us an insight that we can't overload our machines before the part is actually coming out.
Okay.
Okay.
Now, I'm not sure if we've touched, well, we haven't touched on this yet, but in terms of alarm conditions and so forth, could one of the alarm conditions be, could you set an alarm condition of when a machine was reaching, I want to know if I have any machine that's running at 90% capacity, so that there's kind of a flag to me that I may be maxing out on that machine. Is that possible?
We do have multiple, we do have actually like multiple messages that can be sent, and this is all set up when we do the installation.
Okay.
So for example, when I get into the collision and temperature, if there's any variances in the CMM environment, emails and short messages actually can be sent to a specified number of users as well, and automatically.
Okay.
Okay. So now that let's look at the actual collision and temperature portion of the CMM management world as well. This is what we call the onboard diagnostics, and this will actually work directly with a Zeiss C99 control. Okay. So this is one portion of the software that does have to be on a Zeiss machine. So what I'm going to do is actually just pick a machine, and we're going to go ahead and take a look at the collisions from this machine. So what it's going to do is it's going to build a view, basically a plot of all the collisions that ever happened on this machine. This is something that was previously never capable of in the CMM world. So what you can do is we can take a look at any of these collisions here and actually drill down a little bit deeper.
What are we seeing here, the X and the Y axis?
What we see here is actually a collision speed, so millimeters per second.
On the x-axis, okay.
Exactly. And then we see probe head or probe deflection, so how much did the probe actually bend.
Okay. So this is the worst case then in this case would be really high speed, whole lot of deflection.
Exactly.
Parts
so
flying, right.
Down in the green zone, this might be from joysticking and accidentally bumping a part, but it still causes a collision. It's still reported, it's still logged, but it's the full recovery of a machine. Now when we get to these collisions out here, we might want to look at a little bit more about what's going on. If we take a look here, we see a collision and it's going straight down in Z at negative 250 millimeters per second. So pretty much full speed for this machine.
Right.
And then we see the probe deflecting straight up, which is a classic example of a collision. Okay.
Right.
Now, people might ask too, what's the use of this? Now, in a production environment, if you start seeing deviated results, you might want to start looking at the machine characteristics. So we would search for collisions in the past day, the past 2 days, and that can give you a little bit of an insight. Okay, our machine's having issues, we should probably schedule maintenance. So at the end of the day, what we're trying to do is minimize downtime in a production environment.
Okay. Now, is it also possible to send out alarms on this as well? Okay.
Yes, it is. You can set parameters for if a probe head, or if there's a collision over a certain speed and deflection, send out a message to these people. Okay. So you can actually parameterize everything, and this can be done during that initial setup. Now, the other portion of this is the actual temperature of a machine. So I'm going to go ahead and we'll look at, let's look at a different machine, maybe the Acura here. And then what I'm going to do is just do a little time frame as well. Oops. So this is going to be the temperatures recorded over a 3-day period. So we can actually see that this Acura has 5 temperature sensors. Right. And then we can see on the bottom they're actually located in different spots, hence different temperatures. Okay. So the first 3 are the actual 2-part temperature sensors that come on the machine. And then the third one that's actually built into the side of the probe head. And as you can see, all 3 of these monitor the ambient temperature. And here we have a great solid temperature range. Okay.
So that would be that's the parts sensor. So those are external sensors essentially. Okay.
Exactly. Now we have 2 that are running a little bit hotter, and these are actually located inside of the controller. So we have one inside of the controller and one inside of the probe head itself. A recent customer that uses this for basically minimizing downtime, they noticed a temperature spike, and what it was actually a processor fan that was going out inside of their C99. What they were able to do was address this issue before it led to downtime of their machine. So again, at the end of the day, in a high volume production world, this is very important to minimize that downtime and minimize maintenance as well.
Okay, we have a quick question here. Is this software only compatible with Calypso, or can I upload data from multiple machines using other types of software as well? And this is from Chris.
Okay, that's a very good question, and the answer is yes. You can upload information from pretty much any reporting package that you want to. We do have, it depends on what type it is. If there's no automatic uploader for their software, we can create script to do it automatically as well. So if it ever appears in a certain area, we can automatically bring it in, and then we'll still get the same data as well. It's just defining variables, and this is all something we would talk about when we're consulting with a customer.
Now you mentioned the C99, the C99 controller. This is if you're going to get the most use out of this, you're really going to be talking to a C99 controller. That's where you get kind of the full functionality, is that right?
Yes, the full functionality will be on a C99 controller with Calypso running. Now, there are, again, 4 different modules, and then 3 of them don't require a C99 controller, but the one that actually pulls the collision data and the temperature data requires a C99 because that's where that data actually lives. Okay. So the other thing that we can actually do is just get a quick overview of all of our machines in a certain location. If you notice how I have these sorted is by just our different location and training rooms and demo centers around the country. So let's go ahead and take a look at Brighton, and you'll see all my machines that are connected. And actually I can look at the overall status of all these machines. So you'll see that actually 2 of the machines are running parts right now, and there's actually an active countdown for these machines as well.
So this is a real-time display of what's going on with those machines.
Exactly. So this window can be open in a production environment on a screen the entire time, and it will automatically be updating and getting new data consistently. Okay.
We've got another question. This one's from Lind Arnsten. Is the MCC software adaptable to another vision system? If it is, what are any drawbacks?
Adaptable to another vision system. It all depends on the capability that the customer wants out of this. And because again, there are 4 specific modules: reporting, CNC version control, and then we also have the onboard diagnostics and the machine data logging. Now, depending what software they're running, depending what controller it is, it's a great question, but that's definitely one that we should get some specific machine information to address.
So if the Calypso is set up, if everything is set up on a particular machine, even if it's a third-party vendor, but it's running Calypso, at least they can get the Calypso information. Do I understand that right?
Yes, exactly. They can get the reporting, and they can also get the machine utilization as well.
Okay, all right. Okay.
Okay, so, and then that's really the 4 all-encompassing packages. So just as a review, this is a completely scalable product. So if a customer only sees value in one of the modules, that's all they have to buy. So they don't have to buy or actually have additional functionality that they're not important. Obviously, some functionality is important to some industries versus another. So then you can really pick and choose what's important to your particular application. And again, those particular modules are the CNC revision control, where we are able to control our version and versionized documents as well as programs. Okay. Then the next module is our measurement database, which actually stores all of our results that we can easily search them at a later date. And then the 4th module, or the 3rd and 4th module, are rolled into one here. We have the machine utilization module, which monitors machine utilization and also anything coming from the Calypso as well as errors. And then we also have the 4th module, which relies directly on the C99 controller, and this deals with collision and temperatures.
Okay, terrific. Josh, thank you for a great run-through on Master Control Center. Once again, remember, send any questions to techno-live at qualitydigest.com. Even if they're for Josh, that's fine. We'll still have a chance to meet with Josh again at the end of the show and answer any other questions. So, next up, we're going to take a look at a product that is of particular importance to you if you work in the automotive or medical device industry, where surface texture and surface contour are critical and getting even more and more critical. What we're going to look at is the Surfcom 2000, which is a surface texture and surface contour measuring device. and the ACCTee software. And to present that to us is going to be Scott Ledger. Scott is a product specialist here at Carl Zeiss, and Scott's going to tell us all about this software and the hardware. Scott? Okay. Thanks a lot. So tell us about the Surfcom, right?
The Surfcom 2000 is the instrument we're going to use to demonstrate the software. And one of the reasons we're going to use the Surfcom 2000 is because it has a long-range probe. The long-range probe allows us to measure surfaces with a lot of shape in them, where a traditional surface roughness instrument may have too short a range and not be able to measure over those larger features. So that gives us the ability then in the software to do both surface roughness and contour. Which is a little unusual, right? I mean, typically a surface texture machine has got very, very limited, what is it, Y movement, right? And so, Z movement. And but that's where this stands out, right? What is the range of Z movement? With the standard length stylus, it's 5 millimeters, okay, and that can be extended to 10 millimeters if you use a two times length stylus. Okay, so that's quite a bit of range, actually. Okay, absolutely. All right. So what we're going to do in this demonstration of ACCTee is I'm going to take a measurement on the part we have here, but as I do that, I'm going to be writing a part program just to illustrate the ease of programming the software. And so I will be doing a few extra steps that I wouldn't necessarily do if I were just making a manual measurement. Okay. And we'll talk about those as I do them. So basically, if I understand, what you're doing is you're going to kind of manually do a measurement, but as you're doing the measurement, it's going to be creating the parts program at the same time, right? Absolutely. Okay. Yep. So the first thing I want to do is just make sure that my stylus is located where I'd like to start my program, which I'll do with the joystick. And then a really neat tool in this software is called the Peak and Valley tool. All right. And this allows me to find the part, or find a feature on the part. And the feature we're going to find on this part is a valley. All right. So this is an arc shape, and we're going to locate the stylus at the bottom of it so that we know where the part is. Now, is this a peak and a valley location? Is that something that's typically how people are going to reference a part? A lot of times, yes. Really? Okay. Many parts will have a feature on them where you can use that tool to find them. Another valuable tool inside the same tool allows us to locate the stylus within its range. And so we're going to use the column to move the column up and down so that we stay low in the range. Because this valley is very deep in the overall shape of this part, right, we want the stylus to be very low in its range. And so you want the valley to represent basically the lowest part so that everything is up from there and make use of the... Right. All right, okay. And so when we get to the top of the part, or the highest point of the part, we'll still be inside the range of the probe. And we do that simply by setting a percentage of the range that we want to use. And in this case, we've set it for 90%. So when we execute this, the stylus will actually pass through the valley. Okay, so the stylus is actually moving. Yep. Okay, I see it. Yeah, so it's coming down, it's hitting the valley. All right. And then it automatically just locates what the lowest spot is? That's right. Okay, now all that movement's done, and it moved the columns to put us at 90% of the probe range. And so now what I want to do is call this my origin. So I'm going to zero out my scales down here, and now that's our origin for the part. Okay, so everything is referenced from there from now on. All right. Now, I don't necessarily want to start my measurement here because this is kind of in the middle of the part. So now I have to make some moves to get the stylus to the start position. And it's going to be in reference to this scale. Okay. So what I'm going to do is move the stylus back to that position. But before I do that, I want to raise it. I don't want to push the stylus up that surface because I may damage it. Sure. So I'm going to... Styluses are pretty expensive? They are. And I have so you could sell more that way. Yeah, and I have kids in college, so I'd be glad to sell more styli. So what we're going to do is put in a value here. And one of the neat features of the Surfcom 2000 is that it has a motorized stylus lift. Right. And so I can tell it how far up to lift the stylus off of the part. So we're going to do that with a retract of 4.5 millimeters. Okay, and I see that actually the gauge over here shows you that it's retracted all the way. All right. Yep. Now I'm going to manually move it and just visually look to see that I'm at the start position that I want to be.
So this is just positioning it over one end of the unit to be measured. Okay.
That's right. Now what I'll do is actually record that move. So there's a tool down here we can use to record positions, and I'm going to move it to an absolute position based on where the stylus is now, or in this X position of about 8.5 millimeters.
So that's just a manual data entry at that point.
That's right. So we'll just put that in and say OK. And we'll actually execute the move, even though it doesn't move very far, so that it records in our program list up here.
Okay, so when I'm looking on the right-hand side here, I see all the steps so far. I see the peak valley detection, 0 reset, which you did manually, right? The retract, and then positioning, getting ready to start the scan, right? Okay.
That's right. So before we start the scan, though, we want to make sure we drop that stylus back down because it's still raised up. So we'll release it, and that releases it down into contact with the part. Now we can go ahead and set up our measurement conditions, which we do under a dialog right here. And under this dialog, we can set everything the instrument needs to know about collecting this data set. Specifically, it's measurement length. We need to know how far to travel, so we set that here. And we've preset this to 27 millimeters. That's the distance that I need to travel to cover the whole feature on the part that I wish to measure. I can set the measurement speed, and this measurement speed is set at 1.5 millimeters a second, which was a little fast for measuring surfaces, but because
for demo purposes,
we're going to travel a little faster.
Okay.
We can also set the pitch. The pitch determines how many data points we're going to get in the overall trace. And the pitch just simply means the distance between each data point.
Okay.
So right now we're using 0.5 micron. So I have those set. I go ahead and click OK to record that, and then I can go ahead and click measure to take the measurement on the part. And we see the stylus traveling across the part. Okay. And we also see the graphic on the screen as it collects it.
While this is running this trace here, just remember, if you got any questions for Scott, send them to techno-live@qualitydigest.com, and we'll get to them. So that was the end of the trace. There we go.
That trace is complete, and we're automatically sent into the analysis screen. But before we do any analysis, I'm going to jump back to the measurement screen just shortly, because I want to make a move. In most cases, when the measurement finishes, we might want to get the instrument away from the part so that it can be replaced, to put a new part in, and again to protect that expensive stylus.
Sure.
So
it also probably speeds things up. This is just one less move the operator has to do.
Sure.
Okay.
Exactly. So we're going to just put a quick move in. And in this case, I am again going to make an x-axis move, and I'll make it back to 0. And this time, I'll actually do my stylus raising right inside this move, just to illustrate that can be done.
So this is actually 2 moves at once.
Right.
Okay.
It's going to raise the stylus up 1 millimeter,
okay,
and then do the x-axis move.
Okay. And so this is retracting, and that gets everything out of the way, ready to unfixture the part.
That's right.
All right.
Go ahead and release that for right now.
So this would be your entire parts program then, at this point?
These are all the moves for the part program.
Okay.
Now we're going to go ahead and create features on our part. When I bring up this analysis screen, you'll see that I get this list over here of menu items. And each one of these menu items has many features underneath it that I could use to create features on my part, just like you would in CAD.
Sure.
But this can get really busy, and knowing exactly where to go to find the feature that I want can get a little confusing sometimes. So there's a block in here, or a menu item we call favorite, that you can customize and only put those features in it that you're going to use frequently.
And this is global, so anytime you bring up another parts program, your favorites are always going to be there.
That's right.
Okay.
That's right. So in here I have a few features that we're going to use today. One feature that I might want to do to start with is create a line. And the first thing I might want to do is put a line in this flat right here, because that might be my datum on this part.
Sure.
And I want to level the part, or level the trace to that datum. So I'm going to just give it, with clicks on the screen, a range of data to fit a line to. Once I do, it drops the line in, and then I can come back over to my tools, rotate to the x-axis and click on that, and that levels it. Okay. Now, it wasn't out of level to the instrument very much. So
but if it had been, it simply would have rotated, brought it back in level. Okay.
That's right. That's right. And you can see down here, we're building a list of features that we're creating here, which is the other part of our part program.
Right.
So let's go ahead and put a couple more lines in on these legs. We'll put one there and one here. And once we get those in there, we might want to know the angle between them. And again, we could go digging for an angle measurement in these menus, and you can see that I actually haven't added one to my favorites, but I did add a feature here called calculation among elements. And this is a really neat feature in ACCTee. This allows me, when I turn the calculation among elements on, it allows me to feed it a couple of features, 2 features, and then it will tell me or give me the option of all the geometric features I can create between those 2.
Oh, okay, wait. So this is pretty cool. So it will tell you, so based on the features that you've selected, it knows there's only certain types of measurements that you can do. So that's all it shows the operator or the programmer is what you can. Okay, that's.
And the icon is also built to kind of give you an illustration of what that feature is too. Okay. So it's more intuitive. But we're going to do an intersection angle, and as soon as we click on that, it measures that angle and drops a dimension in there right on our graph for it. And with this tool, I can move that around and put it wherever I need it to create more features and make room for other features I'm going to create.
Okay, actually, let's take a question here before we get too deeper. Jim wants to know, does the software have any cross functionality with Calypso? Can you use CAD models? Actually, that's 2 questions, Jim, but that's okay.
We'll take that as two different questions. The answer in both cases is yes. The functionality with Calypso is that you can take a 2D scan with a CMM in Calypso, export that data set, and import it into ACCTee, and do these same kinds of features on that data set measured on the CMM.
Okay, okay.
And as for bringing in CAD data, that's also possible. You can bring in a 2D CAD profile. For example, if you have a profile call out on a profile tolerance call out on your print, you can bring that 2D profile into ACCTee and then take your measurement profile, then best fit it to it, and then measure or actually find out what the deviations are between the measured and the actual.
Okay. Let's take another question since they're coming. We have TIMS software on our Surface system. What are the key differences and can I upgrade? And that's from Brenda.
Actually, we're hitting some of the key differences in the demonstration today, so we'll point out some more of those. One of the key differences is that this is a much newer written software written in today's platforms of .NET programming, where TIMS is an older software. A lot of the functionality, or actually all the functionality that's in TIMS is also in ACCTee, but there's a lot more functionality.
Okay.
And as you see, when I flip through some of these menus, there are a lot more options in ACCTee than there were in TIMS. And there was a second part of that question.
No, that was just, it was, can you bring in CAD?
Oh no, the other part of the question was about upgrading.
Oh, about upgrade, I'm sorry, yes. Can I upgrade, yes.
And yes, the answer is yes. Almost, as far as I know, just about any instrument that's still out there, running TIMS especially, is upgradable.
Okay.
It's just a matter of getting your local Zeiss representative the serial number on your instrument, and then we can cross-reference that serial number to make sure that we get the right hardware with the upgrade. Okay, I'm going to continue here and add a couple of circles in these regions. And automatically it drops the radius in, which by the way is customizable. There are a number of things I could report about this radius, including its center position in relation to the origin, or the diameter, or how round that feature is.
Okay.
Those can all be reported also, and that's fully customizable inside the software. Again, I'm going to just
I noticed it's pretty easy just to move the annotations anywhere you want. Just kind of lay out this picture.
It is, okay. Yes. So now that I've done that, let's look at what happens when I use the calculation among elements with those two circles. Now I have a much bigger list because there are more features I can create between two circles.
But still, it's only the stuff that you could do with two circles. You're no other clutter. Okay.
Right. And what I'm going to do is a distance. And that is the center-to-center distance between those two circles. I might even want to know the height of this circle above that line, for example. I can use the same tool again. Choose that line and that circle, and you see again I get a big list of features I can use, and one of those happens to be this distance DL interval, which is the over-the-top dimension, which might be used in the case of a ball drop or an over ball dimension.
Okay.
So very simple to do. And if I didn't have this tool, I would have to construct that by finding this top point and then measuring a distance from that point back down to that line.
Sure.
Whereas using the calculation among elements, it does it automatically and skips all those steps.
Much faster, right?
Yes. The other thing that we want to do on this profile is measure a surface. And for example, I'm going to measure a surface in this arc. And so I use the roughness of a circle so that the arc shape is removed before we do the filtering for the roughness.
That would make sense.
And when I do that, this dialog pops up that allows me to set some things about the surface roughness. It tells me my total data length.
Right.
And it gives me options for filters and cutoffs, just like you would if you were measuring, if I had measured it as a surface roughness. When I click OK, it drops into my analysis screen a few things. I'm going to get rid of a couple of those. And right there are my parameters calculated on that region of the surface.
Now I see you're showing kind of the typical RA, RZ, RT of your surface roughness. Do you have options for showing other types of surface texture parameters?
Absolutely. With this block highlighted, I can pull up this icon, which gives me a list of
pretty much all of them.
All of them.
Right.
That's right. And by the way, the software, when you're doing surface roughness analysis, you can tell it to which standard, international standard or national standard you're using.
Okay.
And it will only give you the parameter set for that standard.
Sure. And again, just kind of streamlines it for the operator coming back, right?
That's right. Now, we might also want to show where this surface roughness was taken on my trace. So I'm just going to drop in a little arrow line here and put it right there. So what I'm doing, in addition to doing all the analysis on this screen, I'm also building my report. And we had the question about TIMS earlier. What's one of the upgrades from TIMS? This is one of the key features that's different, is in TIMS we had a separate layout page where you created your report.
Right.
In this one, the layout page and the analysis screen are exactly the same screen. You do both steps on the same screen. It saves that step. Plus, this is much, much easier to manipulate.
Right.
No different than manipulating blocks on PowerPoint, for example.
Yeah, it's pretty much drag and drop is what it looks like here.
Yep.
And you can do it to add logos and stuff like that?
Absolutely. We could pull in a JPEG that's our logo, put that in there. Let's move these down a little bit, give ourselves a little bit more room.
So really, you're creating a complete document to hand off to a customer or internal people, whatnot, that's got all the information right there on it, laid out just the way you want to see it.
Exactly.
All right.
Okay. Now that I have that, I might also want to add, for example, last renewal date and a last renewal time. These will update when I execute the part program. So you'll know when this particular measurement was taken.
All right.
Okay. Now that we have all that on there, let's go ahead and save this part program. and we're saving a document.
Now this document has a lot of stuff in it, right? I mean, we've got what? We've got the measurement program, we've got what, the report. What else we got in here?
The raw data is there. All these measurements are there. So when I recall that file name, it's not only my part program, but it's all the results that go with it, including the data set. And this is different from TIMS also, because in TIMS we had several files that made up all this information.
All right.
You had a file called the layout file that was your format for your report. You had a file that was a DAT file that was just the measurement data. And then you might have another file that was just the measurement results.
Well, what's the advantage of having all this in one file as opposed to separate files?
It's much easier to manage for product traceability, for example. Everything that you need to know, all you need to do is save this file, and everything is in that file.
Okay.
Not only are all the results in that file, but you could reload this file and do new analysis on it at a later time.
Okay.
So now that we have that saved, I'm going to close the document. We'll go back to our measure screen, and I'm going to load it just to illustrate how the part program works.
Okay.
So when we open it, our program list is there. And by the way, all of our data is still, the last measurement we took is still there.
All right.
And we'll go back here to
And then we're just going to run it?
measure screen. And we're going to run it. I'm going to make sure the stylus is located properly.
And remember, if you have any questions, send them to us. We're running out of time here, so send them to techno-live@qualitydigest.com. We had a couple extra questions come in for Josh. We will get to those questions at the end of the show. Any further questions for Scott, be sure to send them in.
Okay. To execute the program, all we do is click on the little run icon down here in the corner.
And now it's scanning. There it goes. So everything that you programmed in, and we did some editing, everything was just done all on this one screen, and now we're going to run the program. Now once it's done, this data is going to be created in a new file?
Yes.
So you're going to get a separate file for each run?
That's right.
Okay. All right, and now it's, so it's retracting, getting ready for the actual measurement then?
Yep.
And there it goes. Okay. All right. So what are kind of the three key, what would you say are the kind of the three key elements that make ACCTee software stand out from previous versions of software?
Okay, a couple of them we've kind of already hit on. The all in the document feature, which
single
is
file. Okay.
a single file for all the information about a measurement. The other one would be the ease of manipulating your layout page or your report and making a nice looking report without having to have a separate layout page. And I think the third one would probably be the calibration, which we can jump over and take a quick look at how that works. The calibration now is a single macro, where before it was a two-step process. We use an artifact with a gauge over a ball and over a step. And it was a two-step process. You measured the ball, then you measured the step. Now it's one complete macro that does both measurements. But in addition to that, under the calibration routine, we have a flow chart that takes you through, or in other words, instructions that show you how to do the calibration. So it tells you the steps you need to take before you calibrate. Make sure you have the right stylus loaded with the right conditions. Which artifact am I using? What are the conditions of that artifact, the ball size and the step size, and then it tells you to crown on the ball,
sure,
and then execute the calibration, and that's it.
So it just steps you right through it.
So the instructions are built right into the software.
Okay.
Yeah.
Another question, this one's from Daniel. It's another TIMS related question, but kind of from the hardware end, it looks like. We are using TIMS software and would like to upgrade, but would like to know if we would need new computers and or controllers.
It all depends on the age of the instrument that you have. Many times, if it's a relatively recent, we're going to say in the last 5 years maybe, it might just be a PC upgrade and not hardware upgrade. If it's older than that, we're probably looking at also some hardware that we have to replace for the communication between the computer and the instrument.
Okay. So this is our run, and this is all new data.
All new data.
And it's just populated it on your template that you've already created.
Yes.
Okay.
And I didn't have to save this template special. It was all part of that, all in the document saved.
Oh, and like you said, so even though the data is stored with this file, if you were to open this file and run a program, it's going to store the file as a separate file, but with the new data.
That's right.
Okay.
Yep.
All right. So what else we got on here? We've got. So this, okay, so we pointed out how the surface, can you actually mark on here where the surface measurement was taken? I mean, is it to annotate that in some way if you wanted to know what portion of the curve it was taken on?
Yeah, yeah, you could do that.
Okay.
For instance, if we wanted to
just box it in or something.
Put a box around
sure,
it, we could do that. Around that region. And then I can I would have to remove the fill on it, just like you do.
I see what you're saying. Okay, yeah, it's just like a little drawing program, really.
Exactly.
Okay, all right.
Just like in any typical software that we're used to using.
Sure. So you can just fully annotate. So what we're looking at is the ability to kind of fully annotate your report and take the data all at the same time, all saved in one place. And that's really kind of that, and the calibration stuff you mentioned kind of makes the ACCTee kind of a brand new beast on the
Another nice advantage with the ACCTee software with the part programs is the ability to easily edit the part program. For example, if I needed to edit this position, all I have to do is double click on it, and it brings up the very dialog I used to create that feature.
Okay.
And so all I would have to do is change the position, for example, or change the speed here, click OK, and I've edited my program.
That's terrific. Okay, Scott. Well, man, I appreciate you taking us through the ACCTee software and the Surfcom 2000. I'd like to bring Josh back up. We got a couple more questions here. Remember, if we got a few minutes left. If you've got some more questions, either for Josh or for Scott, send them to techno-live at qualitydigest.com. Josh,
got some questions for me.
Josh, can you kind of come forward a little bit?
No problem.
There you go. How difficult is this software to install? We're talking about the MCC again. How difficult is the software to install? If I have satellite sites, would someone need to go to each site to install? And this is from Karen.
Well, that's a loaded question, but it's actually pretty easy to answer. Depending on how many facilities and clients you're actually going to have, I would say, let's take a number of, like, let's say 10 clients. You're looking at about a day and a half to install, and then we always suggest some training as well. Now, if you do have some satellite sites as well, off-site from your primary location, if we have the ability to remote in and do an install via VNC or some other type of software, we can actually do that all within the same day. But if we have to go to each site, of course, it's going to add additional time as well.
Okay. Yeah, I think this obviously must be for the Surfcom. What is the measurement uncertainty and resolution from Chris?
Well, it's hard to put a number around an uncertainty. We would have to look at the actual type of part that they're measuring and the amount of the gauge range that we're using. But the standard resolution using all 5 millimeters of range is at 16 nanometers. That can be improved by simply reducing the range we use. So if we have a really tight roughness we need to do, we can shorten that range and get up to about 3 angstroms of resolution.
Okay. A couple more questions for Josh. How easy is it to add systems for MCC, and is there a limited number?
That's a great question. There is, since it's a completely scalable system, we can actually just send the user another license, and then it's just installing the clients as well. So if you want machines with only certain clients or have certain modules, you can do that as well. It's completely customizable. And is there a limited number of seats? No. So if you want to do document control, for example, and you only have 1 CMM, you can use the MCC system even though it's just 1 CMM.
Okay. And can I search PDF reports and other data files like Excel and Word?
You can search, exactly. You can actually search the PDF files from the MESPRO DB database, the measurement database, with whatever variables that you think is important. So we'll actually strip everything out of that header information.
Okay.
And then you can, excuse me, one more thing on that, because I saw the Excel, is actually you can export your results to Excel as well from the measurement database.
Okay. See, Scott, this one's for you. Can you put the result data into Flex Reporter or MCC? I think that was meant for you.
Yes.
Actually, for both of us.
Exactly.
I'll let Josh take that
The
one.
answer is yes. We actually do have a customer right now that is using the MCC software to send their surface measurements to it as well. So you can absorb a wide variety of reporting elements.
Okay, I see another question here for Scott. Can you do programs in ACCTee that are analysis only and no machine movement?
Certainly, yes. Where you would load a data set already created and recreate the analysis, absolutely.
Okay. And it looks like, quick check here. Any more questions? Okay. Looks like that's it. Thank you all of you for participating. And Josh, thank you for the demonstration on MCC, and Scott for Surfcom 2000, right. Well, that about wraps it up for TechnorazziLIVE today. And once again, thanks to Zeiss and Josh and Scott. I want to remind you that on Friday mornings at 10 o'clock, we have Quality Digest Live, which is our weekly live program that we're going to be doing every week. It's kind of a recap of that week's top quality news. Be sure to go there. You can find it on our website. It'll also be in our newsletter when you get that. Also keep your eyes open for the next TechnorazziLIVE. We'll obviously send out an email to you like we advertise all of these, and make sure you show up for those. So once again, Scott, Josh, and all the folks here at Carl Zeiss Industrial Metrology in Brighton, thanks for letting us be here. And thank you for joining us for TechnorazziLIVE, and we'll see you at the next one. Thanks a lot.